Alright, part two of the instructions, General Electric Locomotive Section 13 Systems, part two. We're on page 13. 13. The first two types of wheel slip detection employ the current measuring reactors, or CMR. The more the current through each traction motor with the power of the current measuring reactor is developed through a current transformer connected to one output, one of the three phases of the traction alternator of the output of the current transformer is fed with the current measuring reactor. Sensitive adjustment circuit is necessary to compensate for the difference with the motor current between the motor and braking. Each of the constant measuring reactors is connected to an isolation transformer. Their output of the file with a two-path of the first output if they all sum together to form average current signal. With the signal is rectified with the filter to obtain the DC reference level to be sure use sensitive control to make up the difference if the traction motor current is high and low speed. The second path of the isolation transformer from the bridge rectified with the filters to obtain DC output proportional to each of the traction motor current. These DC signals are then compared to the precision reference voltage of the voltage comparison bridge circuit. Under normal operating conditions with the tractive effort, each of the axes with the proportional of the individual motor current, so with the closely matched the traction effort, the braking effort, the motor currents with approximately the same. The error signal is detected with the voltage compared with the bridge circuit, but can respond with the sudden surge for the current due to the rapid traction, unbalanced wheel slip, and K for the sense for the rate detection circuit effect for the comparative of the drive circuit with the circuit compare with the rate of the detection signal with the output from the activity sensitivity adjustment circuit to provide with the current signal to the current constant horsepower excitation control panel. The current active action is to inform the excitation pulse reduction signal. Also, the signal from the rate detection circuit lasts more than 3 seconds to enable the automatic standing circuit. When the wheel slip is more severe in nature with the gradual, longer lasting, unbalanced with the level of the detection circuit is triggered with the voltage comparison bridge circuit with the level of the detection circuit with the sense of the unbalanced phase of the signal of the comparator circuit, which compare with the signal of the taper of the circuit with the signal of the sensitive adjustment and the taper circuit. It also provides energizing signal to the fast response wheel slip relay, or WSX. To open the exciter shield field circuit at the same time, the automatic sanding panel provides the sanded rails. Wheel slip lasts, which is each even longer, as slow as the wheel slip relay will then be energized inadvertently. The corrective action will be taken and bled additional current from the exciter shunt field circuit with also wheel slip indicating lights. The operator controls console will be lit. Alright, these regard against the simulation wheels to protect against overspeed or condition. The third correction path is available. The circuit, the tachometer located in one of the axles monitoring speed of the speed censoring circuit will sense the speed and feed the speed signal to the overspeed detector circuit. With the overspeed condition exists for the detector will energize the wheel slip circuit and necessary for the wheel slip relay circuit to remove the excitation provided with the sending activating wheel slip light. Dynamic braking system. The dynamic braking system is explained with the dynamic part of braking system section in this publication. Sequence of the events occur in the throttle handle with the move of the idle. The braking handle is positioned as shown in figure 13-14. The figure is divided into 4 operation conditions: throttle handle in the idle, brake handle in the setup, brake handle in the braking, and brake handle between minimum and maximum positions. It should be noted that the events that occur with the handles of position occur with a fast rate, with the many events that occur simultaneously. Also, for the simplicity of all circuit, the configuration event are not shown. Engine system monitoring description. ESM, or engine system monitoring, is a protective system that electrically, mechanically, automatically identifies improper locomotive condition and function that provide over-the-road reliability, avoid unnecessary shutdowns, reduce secondary failure. The objective is accomplished, indicating what kind of the maintenance of the work is required with a faulty condition cause the shutdown and road failure. Under most conditions, the engine system monitoring will keep the diesel engine running, although the load and speed may be reduced to match the unit's capability. When problems occur, the malfunction indicating life of the engine control panel is operating capable either signally or in combination to advise the crew maintenance personnel that the problem has developed. Also, malfunction indicating life on an annunciator panel located with the control compartment will be lit by the observing the indication lights. Compare these patterns shown with the engine system monitoring diagnostic chart. Check for the most possible causes. Maintenance personnel can quickly analyze and correct the problem. The engine system monitoring diagnostic chart. The engine system monitoring diagnostic chart, figure 1315, presents the listing with the indication of life of the system condition, including most probable cause of the problems. One of the more engine system monitoring indication life of the engine control panel, or the more indicating lights for the annunciator panel, also will be lit by comparing those illuminated with the chart. Maintenance personnel can identify with the line of the charts to the problem. For example, if there's no battery charge in the annunciator panel and the crankcase overpressure light are lit numbered 1 apply the note the engine control panel line lights column and light numbered 1 divided into 2 sections. The top section lists lights and the lights are a specific problem alerts the train crew with some action may have been taken. The bottom section lights for the annunciator panel light which alerts the maintenance personnel that a problem had occurred or further investigation is warranted. In this case, the action to be taken with the train crew to reset the crankcase overpressure switch, see engine condition in accordance with the recommended railroad procedure. The crankcase overpressure light is on the annunciator panel. The annunciator panel column will remain in the after the crankcase overpressure is reset, indicating that the locomotive experienced the crankcase overpressure problem. After maintenance personnel has resolved the overpressure problem, the lighting annunciator panel could be turned off, lifting off the spring load with the reset the toggle switch on the annunciator panel. The switch will be sealed with a lock wire. The engine condition column lists the various possible engine modes of such shutdown, idling, running, idle, or running. Most probable cause column lists a column of descending order probability to high oil level. The crankcase can be considered the most probable cause. A plugged crankcase breathing screen would then be least likely cause. It should be noted that orderly severity generally increase the line number 1 through line number 10 if any of the indications of one of the upper lines ignored, except the progression to the one lower. If the engine system monitoring diagnostic chart also has the column type to hold relay, the column lists an engine temperature holding relay, and the governor shutdown holding relay. The engine temperature holding relay will pick up if the engine experienced the engine armature over temperature condition. The condition usually causes the high lube oil temperature with the low water pressure, which causes the water temperature to increase above normal operating temperature. The ground safety ground shutdown holding relay will pick up the engine experience very low oil pressure and very low water pressure condition with the governor will then shut down the engine. Equipment holding relays. The engine temperature holding relay and the ground shutdown holding relays, figure 1316, are located within the control compartment near the annunciator panel with a coil. Either relay energized the even monetarily relay mechanical latches is closed, picked up the position red light on the face of its light. Even if the locomotive is shut down on the road, the battery switch is open, the relay will remain latched even until the manually resets. After the problem has been resolved, reset the relay, push the red tab on the relay, push reset. Note, other than holding relays, there are applicable circuitries available with the optional equipment. Your engine control panel, figure 1317, 1318, and the operator's cabs consist of 10 malfunction indication lights to warn the train crew, maintenance personnel, other problems develop. When the problem occurs, the following 10 lights will be lit in either singly or in combination: ground relay trip, overload relay trip, no battery charge, engine over temperature, annunciator panel, governor shutdown, and reduced excitation, crankcase overpressure, engine air filter, hot diodes. Note the engine control panel can be accommodated to additional malfunction indicating lights as a customer option. Then you have your engine monitoring diagnostic charts. We're just going to go down the EC panel lights. No battery charge, annunciator panel, crankcase overpressure, annunciator panel. These are line 2, annunciator panel, engine air filter, annunciator panel. 3 and 4 annunciator panel. 5 no battery charge annunciator panel, governor shutdown. 6 annunciator, 7 annunciator panel. 8 no battery changer annunciator panel, governor shutdown. 9 annunciator panel. 10 engine overspeed temp annunciator panel. 11 engine overspeed annunciator panel. 12 over temperature annunciator panel. 13 overload relay tripped annunciator panel. 14 ground relay trip to annunciator panel, annunciator. 15 annunciator panel, hot diodes, annunciator panel. 16 annunciator exciter, annunciator panel. Figure 1316, holding relay shown in the control compartment. They show the ground relay reset push button, operating voltage relay reset push button, engine temperature holding relay temperature, governor shutdown holding relay Holding relay customer option. Annunciator panel. The annunciator panel, figure 1319, located within the control compartment contained with the mine malfunction light with the lamp test, push button switch, and spring-loaded reset toggle switch. The panel electrically connected directly to the locomotive battery so that if the locomotive is shut down, the battery switch is open and the applicable malfunction lights will remain lit until the alert. The engine control panel, the indicating lights, figure 1317 engine control panel. Maintenance and personnel with the problem has occurred in the 9 lights. The crankcase overpressure 2, the engine paper filter 3, the low oil pressure 4, the low water pressure 5, the low oil temperature 6, generator overload 7, ground relay 8, hot diodes 9 to reduce excitation. A lamp test push button switch is provided to test the lamp. The reset the toggle switch provided the beginning to turn off the malfunction lights after the problem has been resolved. The switch may be sealed with lock wire. Note the annunciator panel can accommodate 3 additional malfunction indicating lights as a customer option. Modulating control governor. The major compartments for the engine system monitors are modified by the control governor. The figure 1320 with the control governor with electro-hydraulic device used to regulate the speed and horsepower output of the diesel engine. Also indicate the number of the auxiliary devices to protect and provide with the power plant characteristics desired for the railway locomotive service. Alright, this shows your engine control panel in the indication lights. Figure 1319 show the annunciator panel. The governor self-contained unit with a mount which is mounted on and driven by the diesel engines, equipped with its own oil supply, oil pressure pump that remotely controlled with the locomotive throttle. During operation, the governor performs 2 basic functions practically: with the control of the speed of the diesel engine, regulating the amount of fuel speed with the engine cylinders at any speed setting of the governor's speed control maintenance and isochronous. That is, governor maintains the constant speed regardless for the changing condition of the load. The second function of the governor is to maintain the constant predetermined horsepower output of the engine for each specific speed setting, accurately controlling the engine load. The control of the engine load is accomplished by adjusting the strength of the generator field to compensate with the electrical load changing of the generator, thus resulting in variable auxiliary loads such as air compressor, battery charging, generator, etc. Our figure 1120 shows the modulating controlling governor, the overfill of the load control brush arm indicator, oil trains, water pressure switch, oil level sight glass, oil pressure switch. Alright, thus, while the primary function of the governor is to maintain the speed engine with controlling both speed with the load condition with the balance established within the result with a consult with a single horsepower output with each of the speed setting of engine, the governor also has the following auxiliary functions: remote electrical throttle control with the 8 notch with the speed plus shutdown position, overriding normal load control operation with the aid of the controlling wheel slip and some application dynamic brake function. 3. Automatic shutdown of the diesel engine in the event of the failure of lubricating oil pressure or failure of the cooling water pressure, and idle speed with the time delay provided with these safe devices permit the starting of the engine while providing the shutdown protection and the pressure fall develop within the allotted time. 4. Limiting fuel supply to the engine during the starting to provide improved starting characteristics. Thus, the governor automatically reduces the engine load when the speed that matches the temporary lower the number of lubricating oil water pressure when the temporary fault condition returns to normal. The governor automatically permits the reapplication of the full load speed and in monitoring no action of the generator operator is required. In the dynamic braking, all the braking excitation is dropped. The diesel engine goes to idle whenever the lubricating oil water pressure is low. After the temporary fault has been cleared, the operator can restore the braking and move the braking handle to the off, advancing into the braking mode. If either the oil water pressure falls to the point where the continued operation will be dangerous, the governor will shut down the engine. Both derating and the shutdown in action with control by the bleeding off the speed setting oil pressure with the governor, bleed off the actuator, the engine lube oil and water pressure acting on their respective diagrams. The diaphragm more plungers regulate the bleed off and the operating low oil pressure and low water pressure switches. For your temperature switches, there are 3 temperature switches. 2 switches are figure 1321, measure lube oil temperature out of the engine crankshaft located externally near the outlet of the oil pump. The third measure with the water temperature 1322 is located on top of the water tank of the water discharge by the diesel engine enters the temperature control compartment. Figure 1321 low and high temperature operating temperature switches. Hot oil temperature switch, cooler inlet, cooler oil fill outlet from the cooler lube oil temperature switch. All right, figure 1322 hot water engine temperature switch of the HWTS nearby components. One is the engine exhaust stack. Two is the engine temperature switch. Three is the pilot valve orifice inspection plug. Four, water outlet to the left bank of the radiator. Five, water outlet to the right bank of the radiator. Six, radiator. Seven, thermostatic pilot valves. Eight, water storage tank. Nine, fluid amplifier flow control valve. 10, water inlet flow control valve. The lube oil temperature switch picks up at 235 degrees Fahrenheit. The switch is mounted on the oil inlet piping of the cooler with the code of the engine contained with the run to the designated speed. However, the load and dynamic braking will be reduced to about 2/3 of the normal for the throttle with the notch. If the low oil temperature cooled with 228 degrees Fahrenheit, the switch drops out full load or dynamic braking is restored. The hot oil temperature switch or hot closes at 235 degrees Fahrenheit. The switch is mounted with the cooler outlet piping which glows at the load and drop, the alarm bell rings and the engine speed returns to the idle flare by after 30 seconds after the alarm is silenced. The latching feature of the engine temperature holding relay, or ETHR, maintains no low the idle speed condition until the manually reset. The resetting should be performed after causing the problem has been resolved. The hot water temperature switch, or HWTS, instead of pick up the 235 degrees, performing the hot water temperature switch is similar to the hot oil temperature switch. As a low load is drive, all oil load is dropped, the engine speed returns to idle for that 30 seconds of the alarm bell ring during this 30-second period. Pressure switch. The pressure switch consists of the crankcase overpressure, the COP switch, or low oil pressure OPS, or low water pressure switch WPS, and engine filter pressure switch EFPS. The crankcase overpressure figure 1323 located on the left side of the diesel engine alternator switch protected the engine for the case of the excessive crankcase pressure. Normal operation slight vacuum of the engine crankcase. The pressure approximately 2 inches in the water builds up, then the crankcase of the switch will trip and shut down the engine. A red indicating light is provided with the device. Also, the engine control panel to alert the alternate operator with the switch and the trip. The switch can be reset pushing the manual reset push button located beneath the indicating light with the device after causing the trip to understand or incorrect the low oil pressure switch and the water pressure switch are located within the modulating governor. Figure 1320, but the action will automatically reduce the engine load speed to massive low oil water pressure with the fall indication returns to normal. Switches automatically restore locomotive to the full load speed. Figure 1324 shows the engine filter pressure switch EFPS, and compressor and governor switch CGS. The engine filter pressure switch is located on the right side of the locomotive of the air compressor compartment. With the switch operates with the junction surface indicator. The figure 1325. The two devices operate with a vacuum and the clean air plenum through accumulation on secondary air filter, primary air clear. Figure 1326 will gradually cover the vacuum clean air plenum to increase the issue. Understand that the filters alone do not create a vacuum. The vacuum is created by the suction of a turbo pulling clean air out of the clear and clean air plenum to the paper filter. Because of the increasingly dirty less outside of the air enter for the clean air plenum to replace the air being pulled out of the turbo, thereby causing the vacuum pressure with the plenum to increase. Our figure 1325 shows the service indicator push reset button. Service indicator figure 1326 shows the engine air filter arrangement. The secondary filter and door opening device. Door opening devices, clean air, bled air, dirt discharge openings, primary bracket bolts. Alright, the service indicator located in the high on the right side of the locomotive has a red band gradually arrive at the service indicator window over the end as the air filters start to get dirty because of the vacuum to increase the full load over the engine. When the pressure reaches the minimum of 12 inches water vacuum, the red band will lock in place, no longer drop with the engine as at idle. The red band movement is visible when the air filter is starting with the get dirty engine is running at the full load. After confirmation of the configuration. Confirmation for the addition with the manometer of the filter elements to be changed. Reset the service indicator. Push the reset button located on the service indicator. If the filter elements are not charged, the vacuum of the clean plenum will be increased at the accelerated rate. The minimum of 14 inches of water vacuum. The engine filter pressure for the switch EFPS, sometimes referred to as the vacuum switch, will strip the engine paper filter. EPFR will energize the engine water, will return to the idle. Also, the engine air filter light on the engine control panel will be lit, and the train line alarm will ring for 30 seconds. After the paper filter has been replaced and the air block debris has been removed, the engine paper filter relay can be reset reset pushing the air filter, fuel pump, and hot diode reset push button on the engine control panel in figure 1318. Alright, figure 1327, hot diode sensor shown in the power rectifier panel. The panel, the terminal strip, the diode, the heat sink, the over temperature sensor, the capacitor diode. Alright, hot diode sensor. 3 hot diode sensors, sometimes referred to as the rectifier over temperature sensor, or OTS, is mounted on each of the 3 power rectifier panels. Figure 1327, 3 sensors react to the rise in temperature, usually caused by lack of cooling the air equipment blower from the independent failure of the rectifier panel. Activation on any of the 3 sensors will cause the rectifier over temperature relay, or ROR, to be energize the alternator to unload the engine to return to idle speed. After 30 seconds, the hot diode light on the engine control panel to light and the train alarm bell to ring for 30 seconds. After the problem has been resolved, the rectifier over temperature relay can be reset, pushing the air filter, fuel pump, and the hot diode reset push button on the engine control panel. Motor circuits and indicators. The motor circuits and indicators are shown in figure 1328. The figures include the lights and the alarms located in the engine control panel, annunciator panel. The operator control console also defines the applicable motor circuit for each of the indicator of reaction. Action resulting should be circuit should be activated as stated before. Variations exist between the different modes of locomotives between railroad customers. Alright, and the last 2 are 2 pages. Alright, this is section systems. That's a little bit too much to explain. You can find this manual at fallenflags.com.